All right, this unit is all going to be about exponential functions, well, this lesson in particular. Exponential functions that we're going to see are typically in this form, y equals a times b to the power of x. Let's look at this website, and it's going to tell us some information about it. You might not be able to see it very well, but I will explain it to you. It says exponential functions look somewhat similar to functions you have seen before. You've seen stuff like that before, and that they involve exponent, but there is one really big difference in that the variable is now the power. So like that y equals a to the bx that we have here, that x is going to remain as an x, as a variable in some of these cases, or in standard form it is anyway. So it's now the power rather than the base. So previously we've dealt with such functions as f of x equals x squared, where the variable x was the base and the number 2 was the power. In the case of exponentials, however, we're going to be dealing with functions such as g of x equals 2 to the power of x, where the base is a fixed number, so this number is constant, and the power is the variable, so that's what is changing. So this is just saying, all right, if we want to graph it, here's what it's going to look like, but I actually have it graphed for us. So exponential function, these are our potential graphs or possible graphs of exponential functions. Every exponential function will look in this form somewhat. This is the graph of y equals 4 times 2 to the power of x. Notice when x is 0, y is 4, because anything raised to the 0 power is 1, and 4 times 1 is 4. In this case, y equals 3 to the power of x. Notice how when x is 0 here, y is 1, because 3 to the 0 power is 1. So these are just possible graphs. The domain for each of these is all real numbers. This is going infinitely in each direction. The range, however, in every single one of these is y is greater than, so the range is y is greater than or equal to 0. It is never going to cross, actually, I don't think it even touches it. Y is greater than 0. It doesn't cross, nor will it ever touch that y-axis, or sorry, the x-axis, in the same range here. So there's a bunch of different application problems we're going to do with exponential functions. The first one is compound interest. It's probably one of the least common ones we're going to use, because savings accounts aren't necessarily used for gaining interest anymore like they used to, but compound interest is actually a very interesting topic. So let's go to this, and let me scroll down so I find it. And you need to write this equation down and I'll show it to you. Okay, compound interest formula. Whoops. The compound interest formula is like it says. Oh, I can't write on here. All right, let me zoom in then. All right. So it's A equals P times, you see those parentheses? I'm going to zoom in here for you too. Parentheses 1 plus r over n and raised to the power of nt. It's an exponential function because our powers are variables. A is going to represent the amount of money after a certain amount of time. P is going to represent the principal. So P stands for the money we start with. So if we're talking about savings account, it's how much money we deposit initially in this case. R represents the interest rate, but no percentages. Interest rates are always represented as a decimal. So typically we're going to be given that value as a percent, so we're going to need to convert it to a decimal. And n is the number of times interest is compounded in 1 year. So if it's compounded annually, it means once. If it's compounded quarterly, it's 4 if it's compounded monthly, it's 12 if it's compounded bi-weekly, it's gonna be 26, because that means it's compounded every 2 weeks, and there's 52 weeks in a year. And T represents the amount of time in years. All of this, right here, I probably need to zoom back out, but all of that needs to be written down. So from the formula for the interest that is compounded is this, and T represents the amount of time in years. All of that needs to be copied down. Because then, so pause it if you need to and copy it. Because then what we're going to do is we're going to practice it as well. And we'll do that in the next video.